Hi everybody, my name is Cindy Jo, and that's how I wake up to go to work. So for 5 years, I've been an accelerator operator here at Fermilab. So tonight, I want to share with you some of the sights and the sounds that make up my daily life. So let's start where I always do, by walking into the main control room. So this is the main control room. It is one of the favorite places for tour groups on site. If you've ever gone on a tour, you've probably been by here. So tour groups love coming by. This is one of the reasons why we have these signs out here. It makes us feel a little bit like zoo animals. People were always taking pictures. Sometimes they tap on the glass. But this really is the heart of the lab. And that beep you're hearing, that's the heartbeat. I'll tell you a little bit more about that later. So why are accelerators so important? Well, the standard model of physics, most of that wouldn't have been discovered without accelerators. Accelerators are a little bit like the microscopes or the telescopes. They're tools that let you see things you wouldn't be able to see otherwise. So we take subatomic particles like protons or electrons and accelerate them up to nearly the speed of light. And that extra energy allows us to see things about the particles that we wouldn't be able to otherwise. Let us set up rare situations that are not readily available in nature and study them in a laboratory setting. So these particles were actually discovered at Fermilab, which makes them the best particles. So this is the accelerator complex. So we have 6 accelerators, miles of tunnels, dozens of service buildings, all spread out over a 10 square mile site. There's a lot going on here. So normally we're sending beam to 7 different experiments at the same time. So a squirt of protons, that's what beam is, starts in the ion source, accelerates down the line, around the booster, into the main injector, and then out to the different experiments. So remember, I told you I would get back to what that beep is. So the beep, which we call the beam tone, is correlated to the amount of beam that is in the main injector. So operators, and now you guys, can tell exactly when there's some sort of problem that leads to less beam being in the machine. You can hear the pitch go up or down. For those of you who are paying attention, there is this one low pitch that you hear with a big pause after it, and that's actually a smaller amount of beam that we're sending to some of the experiments. So I want to get into a little bit about the parts of an accelerator. So even the most basic accelerators on site have beam pipe, RF cavities, those are the things that accelerate your beam, magnets, those bend and focus the beam, power distribution, low conductivity water systems, those are what do the cooling. Vacuum, which keeps the beam pipe empty of everything except the beam. And finally, the controls and diagnostics, those are what we actually use to see what's going on. So all of that times 6 different accelerators ends up being more than 250,000 things which operators watch and control all of the time. So operators are on shift 24 hours a day, even overnight. That's what we call the owl shift. 365 days a year, including weekends, Christmas. This is a picture I took my first Christmas at the lab. Thanksgiving. This is something that I cooked up last year, and it was delicious, let me tell you. And Super Bowl Sunday, which some people would consider a holiday. When the lab is closed, so operators are considered essential personnel, which means that we always show up. So do you guys remember the snowpocalypse that happened in February 2011? So this is my coworker, Chris. He is going out on snowshoes in order to reset a radiation monitor. Within 5 weeks, we cycle through all 3 shifts, day shift, evening shift, midnight shift, and back again to day shift. Sometimes we have 12.5-hour shifts. And even though we have a lot of help from a lot of people, there are actually only 3 or 4 people on shift at one time. So this is what I spend most of my time looking at. This is one of the things that you might see if you're looking at the screens in the main control room. This is called ACNet, which is the Accelerator Control Network. This is the alarm screen. So it tells us if there's anything that is out of tolerance or going wrong, like that. Honestly, this is not what it actually looks like, but it's the gist. It's a metaphor. Just work with me, guys. So we have to fix it.
That was easy.
All right, moving along. So let me tell you a little bit about operators. We all have college degrees, but we don't have PhDs. You can get a degree in accelerator physics. It is real. It is interesting physics. I don't have a lot of time to get into it right now, but most of us did actually study physics or a related field like engineering. Actually, when I was in college, I worked at a nuclear reactor as an operator there. But we have had meteorologists, geologists, history major. It takes around 2 years of on-the-job training just to have a basic understanding of the accelerators. Operators either have or learn really good sleep and awake powers. We also all have iron stomachs. I should mention that experiments like this one, which send us food, get more beam. And operators do whatever's necessary to keep the beam running. Sometimes that means you just roll up your sleeves or your pants legs, or well, you don't roll up your pants legs, I guess, sometimes. And you get dirty, you do what needs to be done. The most important characteristic of an operator is curiosity, skill, a knack for figuring out what's going wrong, and interest. So let's look at the alarm screen again. Oh, you guys heard the beep went away, right? That means there's a problem. And in fact, looks like there is a ground fault in the main injector, which means I need to suit up and turn things off safely. So this is what I wear to protect myself from an arc flash while I suit up, or while we turn things off so that people can go in and do their work. So normally there would be a lot of searching, but I get the impression that there might be something wrong with this transformer. So, what's wrong with this transformer? You guys, I think I found the ground fault. You might not believe me, but this actually happened. All right, so snakes are not the only animals we need to deal with. There's a lot of others that cause us problems. I would not like to be the person who had to call in the artillery strike to deal with this wasp nest. But let's move on. So let's look at the alarm screen again. After a lot of work, we've got things going again, but then there's another problem. I think there's a water leak of some sort. I think I'm going to have to investigate again locally. So, what's going on over here? Is this power supply working okay? There was a water leak. This also actually happened. All right, well, get things going again. So I hope I've convinced you today why operations is the best. I hope I've convinced you a little bit about some of the unsung heroes of the lab, why what we do is interesting, why what we do is vital. There's some people that you're going to hear talk tonight that work on some experiment or another. What they do could not happen without what I do. Experiments come and go, but operations is forever. So it is my job. I do get paid for this, but I think you wouldn't be wrong in saying that it's a labor of love. So earlier, that was my real schedule. I actually really do have to go into midnight shift tonight. So can I get some support for that?